Hi everyone, I am Milano. So we're gonna tackle about calculating the period and the frequency of spring mass, simple pendulum, and physical pendulum. First, we're gonna talk about spring mass. So spring mass is a mass to attach. Spring moves back and forth due to restoring force, Hooke's law. So, spring mass system is a setup where mass is attached to a spring and it moves back and forth when stretched or compressed. This back and forth motion happens because of a restoring force which allows Hooke's law, and Hooke's law is a state that the force proportional to how far it's stretched or compressed. So as you can see the right side of my slide, it is about spring mass systems formula. Period is equals T is equal to 2 pi square root of m over k. Then the frequency is F equals to 1 over T equals to 1 over 2 pi squared square root of k over m, where m is equal to mass or kilogram, while k is equals to spring constant Newton per meter. So next, let's proceed to spring mass example. Let's hear from the problem. A 0.5 kilogram mass is attached to a spring with k is equal to 200 Newton per meter. So let's see the solution. So what I have said earlier about the problem of a 0.5 kilogram mass is attached to a spring with k is equal to 200 Newton per meter. So this is the solutions I do. The given is equals to m is equal to 0.5 kilogram and the k is equals to 200 Newton per meter. The formula is time is equals to 2 pi square root of m over k. Next is 2 pi square root of m is equals to 0.5 kilogram over 200 Newton per meter. 2 pi square root of 0.5 kilogram over 200 Newton per meter is equals to 0.0025. The next is 2 pi, the square root of 0.0025 is equals to 0.05 seconds. So we're gonna multiply this 2 pi times 0.05 seconds. So our final answer is 0.314 seconds. Next is the F. F is equals to 1 over T. Next is 1, and then our time is 0.314 seconds. You're gonna put it here, and our final answer is 3.18 SC. Thank you so much. So next, we're going to tackle about simple pendulum. So a simple pendulum is a small mass suspended by a light string that swings under gravity. It's called a bob, suspended from a light string that swings back and forth under the influence of gravity. Its motion is periodic, meaning it repeats in equal intervals of time. The time it takes to complete one full swing is called the period T, or time, given by the formula T is equals to 2 pi square root of L over G, or length over gravity, where L is the length of the pendulum in meters and G is the acceleration due to gravity, 9.8 meter per second squared. The frequency F is the number of swing period, and it is the inverse of the period. This shows that a longer pendulum swings slower while the shorter one swings faster. So as you can see to my right side of the slide, there's the period. Period is equals to time. Period formula is equals to time equals to 2 pi square root of length over gravity, while the frequency is equals to F equals to 1 over time, or 1 over mlg over gravity, where L length of the pendulum, m, then g is the acceleration due to gravity, 9.88 meter per second squared. So let's do the solution so that you can see how we will solve it. So here's the simple pendulum example. A problem that a pendulum has length is equals to 1 meter, so we need to find its period. So let's gonna solve this. I will show you the solution. So what I've said earlier about the problem, a pendulum has length equals to 1 meter, so we need to find its period. So this is the simple pendulum I do. I already solved it. I'm just going to explain it to you guys. So time is equals to 2 pi square root of L over gravity. This is just like the same about the spring mass formula. The different is the length is over gravity. So 2 pi square root length is equals to 1 meter, then gravity is over 9 meter per second squared. So 2 pi square root of 0.102, that's because 1 meter over 9.8 meter per second squared is 0.102. So 2 pi times 0.319, that's because 319 is the square root of 0.102. That's the answer. Then the final answer is 2 pi times 0.319 is equals to 2 seconds. So we need to find the frequency. 1 over time is equals to 1, that our time is 2 seconds. As you can see, 1 over 2 seconds is equals to 0.5. So that's the answer of the simple pendulum problem that I said. Next, we're gonna talk about physical pendulum. So physical pendulum is a rigid body like a rod or plate, pivoted point swings back and forth. So that swings, physical pendulum swings back and forth around a fixed point when displaced from its equilibrium position, unlike a simple pendulum, which use a small mass and a string. A physical pendulum considers the distribution of mass within the object. The time it takes to complete one full swing is called the period, or T, and it's given by the formula T is equals to 2 pi square root of L over mgl, where L is the moment of inertia and kj times meter squared. M is the mass in kilograms, while g is the acceleration due to gravity, 9.8 meter per second squared, and the L is the distance from the pivot to the center of mass. This shows the motion of the pendulum depends not only its mass and length but also how the mass is distributed. The larger the moment of inertia, the slower the pendulum swings. So here's the physical pendulum example. a problem that a uniform rod of length 1 meter and the mass 2 kg is devoted at one end. So let's gonna solve this. First, we're gonna solve the moment of inertia about an end. Next, the center of mass center of mass distance, and then next the time and the frequency. So let's gonna solve it. So as what I've said earlier, the problem of a uniform of a length 1 meter and mass 2 kg is pivoted at one end. So this is the solution that I do earlier, the physical pendulum. So first we need to solve the moment of inertia. So this is the formula. 1 is equals to 1 over 3 ml squared. So 1 over 3 Rm given is 2 kj, that's why 2, and L is 1. So 1 squared. So you just gotta multiply the 3 and the answer, final answer of R length is 0.6667 kgm squared. So next is our center of mass distance. So our formula is D is equals to length over 2 equals to 1 half times 1, that is equal to 0.5 meter. So let's proceed to time is equals to 2 pi square root of L over mgd. This is the formula of physical pendulum time. 2 pi square root of RL is 0.6667 kgm L. Then our mgd is M is equals to 2 kj and G is 9.8 meter per second. This is the gravity, and our D is 0.5 meter. So 2 pi square root of 0.67 kgm, just to multiply this 2 kj 9.8, then the 0.5, and the answer is 9.8. Let's proceed. 2 pi square root of 0.0681, that's because 0.667 kgm over 9.8, and the answer is 0.0681. So let's proceed. The square root of 0.0681 is equals to 0.261. 2 pi squared times 0.261, and our final answer is 1.64 seconds. So let's go to our frequency. 1 over t. 1 is 1 over 1.64. That's because our time is 1.64 seconds. 1 over 164 is equals to 0.61 C. That's all for the physical pendulum. Hope you would understand.